online. I'm Steve's son. I'm in mechanical engineering with a courtesy in Aero, and I work at Zucro Labs. My area is in combustion, and in particular, combustion of energetic materials. And those are propellants, explosives, and pyrotechnics. So part of that's related to propulsion. Professor Lucht will do an overview of our Zucro Labs, where most of our propulsion work takes place. Bob, do you want to introduce yourself, and we'll introduce everybody else too?
Yeah, I can. Why don't I go ahead and start the presentation? And
let's introduce all the professors first.
Oh, I was gonna. Let's do that after.
Okay.
Show their pictures.
All right, that's fine. Go ahead.
Okay, so I'm Bob Lucht, and so I'm going to give an overview of Maurice J. Zucro Laboratories. So it's a laboratory complex that's by the airport. You can see the runways there at Purdue. So we're pretty far off campus because of people like Steve, who do work on explosives and pyrotechnics, and also we do a lot of high pressure combustion work, both in rocket propulsion and gas turbine propulsion. So this slide has the faculty members that are associated with Zucro Laboratories, and a number of them are on the call here. And so I'll be talking for about 20 minutes just to give you an overview of Zucro Laboratories, and then we'll try to leave 25 minutes for discussion, and then a number of the professors are on the call, so you can ask questions of them directly, and then maybe they can screen share, or I have some slides from them also. But on the Zoom meeting right now, I know I saw Monique McLean log on, Guillermo Paniagua. They're both from mechanical engineering. Steve's son is the moderator, also from mechanical engineering. And we have faculty members from the School of Aeronautics and Astronautics and School of Mechanical Engineering. So almost all of us have courtesy appointments in the school that we're not a primary faculty member is. I believe Tim Pourpoint is on. Also, he's in aeronautical engineering. And Steve Heaster, I know, is on as well. And so he's also in aeronautical engineering. So we do have one professor, Davin Piercy, whose primary appointment is in materials science engineering, and that may become more and more important in the future, especially as we move into topics like hypersonics at Zucro Laboratories. So this is an aerial picture of the lab from about 2016.
Hey, Bob.
I'm not seeing the slides.
You're not seeing the slides? Any of the slides?
You did something and changed, it looks like.
Can you see them now?
Yes.
So did you see any of the faculty members?
Yeah, we saw that slide, and then when you went to the next one, we lost it.
Okay. Let's see what happens now.
Just lost it again.
Lost it again. Okay. Let me stop sharing and
maybe stay out of the presentation mode.
Yeah, that's what I'm thinking. Is it might be the issue there. So
if you have multiple screens, it could move it out.
Yeah, there's a lot of stuff going on the screen. So let me escape and okay. Can you see that? Okay, so I'll just make it a little bigger. I'm getting a lot of things like see the waiting room and things like that. So anyway, so this laboratory complex was started after World War II when Purdue hired Dr. Maurice J. Zucro, who was a senior scientist or high up in the administration of Aerojet Corporation out in California. So that there was a lot of work during and right after the end of World War II in both rocket propulsion and jet propulsion. And so those were the two main thrust activities for the new laboratory. And we still have some of the buildings from the initial establishment of the lab. We have down here ZL4, the buildings are numbered kind of alphabetically, and that's the propulsion lab. So that was one of the first laboratories that was developed. The combustion laboratory, the first part of that was built in 1952 and then added on to in 1955, and then various buildings over the course of time up to about 1973. And then for about 40 years then, we didn't have any more new buildings. So in the last couple of years, we've had a lot of new construction actually at the laboratory. And one of the buildings that we're quite proud of is our new high pressure combustion laboratory. And this laboratory is has 5 modern test cells, and it's designed around a central laser laboratory. So that's one of our claims to fame at Zucrow Laboratories, is our emphasis on laser diagnostics for looking at gas turbine combustion, rocket propulsion, combustion of energetic materials. And so back when Zucrow Laboratories was established, nobody had, the laser had not been invented yet. So our buildings were not really appropriate for a modern combustion and propulsion research with laser diagnostics. So we're moving forward on various building projects. And so the research activities that we have going on right now have to do with gas turbine propulsion, rocket propulsion, and energetic materials. And we have very active faculty in all those fields. So we'll have a couple slides later on Professor Paniagua's turbine research. This is the actual turbine part of the gas turbine engine. And so he has a cell in the new combustion laboratory, a new high pressure combustion laboratory that's devoted to turbine research, and it is now fully operational. And we've also recently hired a new assistant professor, research assistant professor, James Brown, is also very much involved in that research. And so he's also taken over or been establishing a new laboratory in one of our other buildings for setup of instrumentation for very sophisticated measurements of turbine properties. So we've also are very strong in gas turbine compressor activities. So this is primarily under the guidance of Professor Nicole Key, who does a lot of work with Rolls-Royce, Honeywell, O&R, Office of Naval Research, and other agencies. And we're just about to complete a couple new test cells for compressor research. I'll show you a photograph of those in just a couple of minutes. We do have a lot of gas turbine combustion research going on with Professor Slaybaugh and Heister in particular, doing a lot of very interesting work on a new concept, rotating detonation engines for gas turbine research. We also have work going on with the FAA and GE Aviation on gas turbine combustion research, and that's primarily Professor Slaybaugh, also Professor Gore, and myself work in that field. And in particular, we have an optically accessible gas turbine combustion rig that's capable of operation at pressures of 60 atmospheres. So that's very unusual for a university laboratory, to say the least. So there's a lot of activity also in energetic materials, and this really doesn't do justice to us, to that sort of activity. Within the last month, we have a new $8 million center activity initiated with the Army that Steve Sun and Jeff Rhodes, who's not officially associated with Zucrow Laboratories, have done the work of bringing that center activity to Purdue. Also Steve Bowden from chemical engineering. But a lot of that activity will be going on at Zucrow Laboratories by people like Davin Piercy and Monique McLean and others. And so in support of those new types of activities, we've renovated ZL4, our propulsion laboratory, to install new fume hoods that are very sophisticated fume hoods for the synthesis of new energetic materials. That's Davin Piercy's field of research. And then we've got a lot of research going on in rocket propulsion, and that just seems to be getting busier and busier, working with companies like SpaceX, Blue Origin, and Stratolaunch. And we have a new project with the Department of Energy to look at validation experiments for ignition in rocket chambers for outer space. And then Professor Heister is one of the country's leading experts in RDEs for rocket propulsion. And you can see the very really pretty picture to the right. That's a rocket engine operating on an RDE burning kerosene. That's Professor Heister's work. So in terms of new construction, this is a new test cell, 2 new test cells for compressor research that you can see the picture here from August, and then the big picture from a couple weeks ago. So these test cells.
Hey, Bob,
Yeah.
sorry to interrupt. I'm not seeing you paging forward. Is everybody else seeing?
Yeah, it froze, Bob, again.
Froze again? Okay,
So
thanks.
We're currently stuck on the overall map of Zucro.
Really? Okay. Okay, there's something going on. I need to stop share and then share screen again. I guess I'll have to do that. Can you see it now?
We'll try to let you know. I just wasn't sure if you were intending to page forward, but
Yeah, I have been. Can you see that?
yeah.
See the screen now. Okay, so I'm, yeah, just let me know. I am paging forward. So let me go ahead. So these are 2 new test cells that are being constructed, specifically a new compressor research project from the Office of Naval Research will be taking place in these test cells. And this is, excuse me for a minute. My beagle decided to protect the house. So these are, can you see these test cells? Or these fume hoods? These are the new fume hoods that will be used for synthesis, among other things, synthesis of advanced energetic materials by Dr. Piercy and other researchers in ZEAL4. So we are really well set up for very sophisticated energetic material synthesis at this point. So this is Professor Key, and so her work is on compressors, and so this is a centrifugal compressor project that is sponsored by Rolls-Royce, and so she works at the leading edge compressor research, and so she's got a very, very active program with both industrial and federal sponsors for her work. And she also does a lot of sophisticated measurements, both with lasers and with other types of physical probes. This is Professor Paniagua's group. This is from, I think, last year. And his group is the Purdue Experimental Turbine Aerothermal Lab. And you can see the test cell in the new high pressure combustion laboratory where he does his research. And so the scale of the research that we do at Zucro Laboratories is really unusual for university laboratories. And he has some of the largest test rigs that we have at the complex. And so here are some of his test rigs. And so this, his research takes advantage of our air compressor system, where we have one of the largest air compressor systems for university research in the country. And we also have excellent vacuum capabilities for this type of research. He pulls a vacuum on the turbines so he can get the appropriate pressure ratio across his turbine test rigs without having to have very, very high pressure air going in. And he has a number of different very active test rigs in his particular laboratory cell. And so in the picture down here on the right, you can get some idea of the scale of the experiments that are going on in this particular test cell. This is a gas turbine combustion test rig that Professor Slabaugh and I work on, and currently we're doing work under sponsorship from the FAA to look at hot fuel, the effects of injecting hot fuel into the combustion.
Hey, Bob, it locked up
Yes.
again.
Locked up again. Okay, I'll stop share. Thank you.
Go back to slide 12.
Slide 12. Okay. Oh, okay. Can you see it now?
No.
Oh, not yet.
No, I got a
Looks like
little.
it looks like it's coming back up.
Is it up now? I had a little spinning wheel.
We have a bandwidth problem, huh? So many people on, or?
Okay. Zoom quit unexpectedly. So, okay. So stop share.
We can still see you, Bob.
You can still see me? Okay.
Yeah. So we just need to get your sharing back on again.
Okay. Can you see that now?
Yeah.
Yeah.
Good.
Okay. So this gas turbine test rig is unique in that we can simulate conditions at full power conditions for one injector of a gas turbine engine. And so that thermal power is 8 megawatts, and we can handle conditions up to 600 psi and 1400 Fahrenheit for the inlet air temperature to the combustion test rig. So this is has excellent optical access, and so we can apply all sorts of laser diagnostics, including high-speed PLIF and 100 kilohertz PIV, and later on coherent anti-Stokes-Raman scattering in here in this particular test rig. So Professor Slabaugh and also Professor Heister. Professor Heister does research on RDEs and rocket engines, and Professor Slabaugh is concentrating on rotating detonation engine work on gas turbines or pressure gain combustion. And so this has the potential for giving us 4 to 7% gain for simple cycles and 1 to 3% gain for combined cycles. And I'll try to hurry through these. Professor Meyer and Professor Slipchenko do a lot of sophisticated laser diagnostics in, as it says here, extreme environments, high pressure, turbulence, hypersonics, detonations, and multi-phase flow. And in particular, they are world's experts in the development of pulse burst laser technology and pulse burst imaging techniques for combustion diagnostics. Professor Meyer does what's called 4D imaging of turbulent combustion using pulse burst laser technology. And he also does a lot of very interesting work in sprays, in particular using X-ray imaging. Monique McLean is one of our new professors, or she will be starting as a new professor in the fall of 2021. And her research expertise is in additive manufacturing, especially in additive manufacturing of explosives and energetic materials. And so here we see some of the energetic materials in action, and she is currently doing a postdoc at Oak Ridge National Laboratory to get even more expertise in 3D printing of energetic materials and other materials. Steve Sun, who's our moderator, does a wide range of work in energetic materials. And so he does everything from engineering energetic materials at the molecular level to characterizing them in small scale experiments to then performing experiments, large scale experiments, including even the launch of a rocket using a an energetic material propellant that he had developed in his laboratory. So Professor Pourpoint in aeronautical engineering does a wide range of work in things like hypersonics and in space thrusters. And he also does a lot of very interesting work in liquid propellant research. And then finally, we have Professor Gore and Professor Hosty. Professor Gore and Professor Hosty is a new research assistant professor, but they do a lot of work on computational fluid dynamics using a new computational technique where they use adaptive meshing in their computational fluid dynamics. And so they can actually model in a very realistic fashion gas turbine combustion processes, which is a very, very sophisticated and complicated process to model. And they have recently gotten a very large grant, and so they're moving rapidly into doing data science and artificial intelligence to look at combustion processes. In particular, they got a very nice grant recently from the Department of Energy to look at whether they can use artificial intelligence and data science to program the activities of small coal-powered power plants that are often rural areas to see if they can manage their operations to be much more efficient. And this is becoming more and more important as renewable energy sources are integrated into the electrical grid. So I kind of went through those. Can everybody still see the slides?
Yeah, they look fine. Are you
okay,
done?
so finally that got worked out. So I wanted to get through those slides and open the floor up to questions.
Well, before we start that, let's. I know Guillermo Paniagua, Professor Paniagua, has to go to class. So Guillermo, could you introduce yourself briefly? I know you were introduced in the slides, but maybe you can introduce yourself briefly and take any questions before you have to run to class.
Yeah, sure. Thanks, Steve. I'm originally from Spain. I spent about 20 years at the von Karman Institute, leading research on high-pressure turbines and high-speed propulsion. So here at Sucro, we have built several test sections from subsonic all the way to supersonic. And yeah, I'll be very happy to take any question now.
And also, maybe we could introduce Professor Pourpoint, who also has to go to class at 4:30 as well. And then we'll direct questions to both of them before they leave. Tim, could you introduce yourself very quickly?
Yeah, happy to. Thank you, Steve. So yeah, I'm Professor Pourpoint on slide 18 there on the screen. A lot of what I do, as Professor Luck said, is liquid propulsion, really for space exploration, which is my passion, I guess. And that leads me to work on many missions for NASA. Recently, for example, we worked with JPL and a lot of folks at NASA Marshall on a mission on a possible mission to Mars, or at least an architecture for a mission to Mars. So if you're interested, don't hesitate to send me an email. My email address is right there, Timothy with 2 E's at Purdue.edu.
All right, let's take any questions that we have right now for Professor Paniagua and Professor Pourpoint. And you've got Professor Paniagua's email in the chat as well, so you can contact him. Oh, okay, there's Mena has your hand raised. Go ahead and come off mute.
Yeah, that's me. So first off, thank you all for hosting this event, or particularly this Zoom session for the Propulsion Research. So I actually do have a question for all the faculty members before Dr. Pourpoint and Dr. go to their classes. So this is like a general question. Aside from the admissions office and all their great admissions criteria, what will you be looking for? What would you like to see in the application for a PhD program? Like, I don't know, like what would make a PhD applicant stand out to you in your very own perspective?
Do you have a particular area of propulsion, Mena, that you're interested in?
Yeah, it's rocket propulsion, liquid propulsion.
All right, Tim, why don't you take that question of what you're looking for in an applicant?
Sure, yes. And in fact, Mena, good to see you again. I remember you from the liquid propulsion short course with the AAA.
Oh, that's great.
You know, I think it's hard to say rocket propulsion, in particular chemical rocket propulsion, without having a good understanding of chemistry. So I have some molecules drawn up there on that slide for that reason. So I think that is an important aspect to work in my group in particular. And then you know, the second part of this is engineering. So having an understanding of what that means, of the various processes, the high pressures we deal with, the flow rates we deal with, the corrosiveness of some of the fluids, toxicity of others, is important. Yeah, I think that in a short time frame, I think that's what I can tell you.
Yeah, that answered my question. Thank you so much, and good to see you again.
Very good.
All right, other questions in particular for Guillermo or Tim?
I have a question.
Go ahead, Raj.
I'm really interested in rocket propulsion, but I'm a professional master's student. So is there any opportunities there for professional master's students in particular?
Professor Heister, do you want to take that?
What do you mean by professional master's student?
So I was thinking about taking, I think, working in like industry. So my goal was to finish my master's in 1 year without thesis.
Mm-hmm.
So I was wondering that, is there any particular, like, alongside taking any classes, like taking particular classes, is there any way that I can get involved in any groups?
Well, Professor Slaybaugh teaches our graduate level design build test course in the spring semester. And if you're actually on campus, that would be a good opportunity for some hands-on experience. He's done a number of things over the years there, projects from supporting NASA flame duct facilities on the at NASA Stennis Space Center to projects for Burning Man. So students actually get their hands dirty there, and in fact, we're poised to test a rocket engine that they designed in the spring semester here in the next few days.
Thank you so much.
Thanks, Dave. And another option, Rob, is to do research for credit too. You may want to look into that.
I'll do that. Thank you.
Any more questions? If not, let's introduce the other professors online. We have, see you, Guillermo. Terry Meyer, who I see up at the top. Do you want to introduce yourself and talk about what you do in the propulsion area?
Sure. So yeah, my name's Terry Meyer. I came to Purdue about 5 years ago. And prior to that, worked at Iowa State University for a number of years and the Air Force Research Labs before that. And so my primary area of emphasis is in sort of detailed understanding of complex flow processes at these extreme conditions, as Professor Lux said earlier. And so I do a lot of laser diagnostics to try to understand high-speed flows, turbulent flows, multi-phase flows like sprays, combustion, and energetics. And so I do quite a bit of collaboration with a lot of the professors here. I co-advise a good number of students as well, combining laser diagnostics for these types of systems, for rocket propulsion, energetics, et cetera. I also have my own laboratories where I do work in rotating detonation engines, high pressure combustion, turbulent combustion. And so we set up basically smaller scale experiments So these are not the practical scale rotating detonation combustors like you might see in Steve Heister or Carsten Slaybaugh's lab. They're designed for optical access to try to, again, get at the details of these processes. And that's my primary focus.
Thanks, Terry.
Can you see my screen there, Terry?
It's all black.
No.
It's all black.
Yeah,
okay,
you're
I'm
probably
trying to
show
show
something.
you. Okay.
Yeah,
All right.
Monique McLean, can you introduce yourself?
Yes, hi everyone. I'm Monique McLean, and my main background is on 3D printing energetic materials, in particular propellants. So I want to continue some of this work, but I'm also interested in combining 3D printing techniques to print dissimilar materials. Also interested in monitoring the process of 3D printing and answering more fundamental 3D printing questions, but with application of propulsion.
Thanks. Steve Heister, if you're still on, would you like to introduce yourself more?
Well, I think Bob and others have talked about me. I think I should say a little bit more about the whole group in Aero and Astro. We have six faculty in the propulsion area. So Professor Anderson has not been mentioned. His work mainly in combustion stability, internationally recognized expertise there. He's not terribly active research-wise, but you know, a resource for you if you get interested in that topic. And then Professor Wang, Haifeng Wang, does computational work on combustion problems with PDF methods. It's quite a unique approach. A lot of emphasis on the subscale modeling processes. Diffusion and mixing at length scales that we simply can't model because the molecules are too small. I think the others, Professor Shao, we haven't talked about too much. She's got an active program. She's working gas turbine combustion, ignition problems, microcombustors. She does some fundamental kind of combustion bomb experiments, as well as molecular dynamics simulations. Professor Slaybaugh has been mentioned, and Pourpoint you just heard from. So that's the group in Aero-Astro. As Professor Lucht pointed out, you know, we've got combustion and propulsion people in both mechanical and aero engineering, and we work together out at the Zucro Lab Complex.
All right, thanks, Steve. Are there questions for any of the professors here? You can raise your hand. You can type in questions. Good. Chandra, we have a question. Do most of the projects involving propulsion require the students to be U.S. citizens? I'll go ahead and answer that, I guess. A lot of them do, but there are some that don't. And so we have both U.S. citizens and international students. Anybody else want to add something to that, Terry?
Well, I was going to say, Professor Luck, do you know what percentage of U.S. students, overall in mechanical, at least it's something like 70% international, but Zucro in particular is not the same as the rest of mechanical. Well, it's a mechanical aero lab for one thing, but Bob, do you know at Zucro what the percentages are?
No, I don't know what the exact percentages are. That'd probably be a good thing to for us to figure out. But I would guess it's 70% U.S. citizens at Zucro Laboratories. You know, a lot of the projects in rocket propulsion, in particular, require U.S. citizenship. But
that's about the same percentage.
We do have, and I know we do have a number of international students. I have two international students at Zucro that are graduating this fall that were supported by projects with Siemens Corporation and projects with the FAA. So, you know, so it just a lot of the industrial projects are the ones that require U.S. citizenship, actually.
Okay, and then Edwin asks, what about U.S. permanent residents? And in general, for a U.S. permanent resident, that there's not a problem, that they're essentially equivalent to U.S. citizens. Bob, you wanted to stop sharing your screen? It's just black anyway.
It's just black? Okay, yeah, I was wondering if it was, so I was trying to show the faculty members again.
It just keeps going away.
Sharing is just not working. Okay.
In fact, Ed, when I had a U.S. permanent resident student, and he recently became a U.S. citizen and really didn't change much.
Yeah, let's see.
It's a quiet group. Got to be more questions out there.
It's probably a big group, so people are feeling a little bit shy. But,
oh, here
yeah.
we go. Griffin, is a security clearance helpful for some research opportunities at Zucro? I haven't found that it doesn't hurt, but I haven't found that it necessarily helps in any particular project. It's a good thing.
Right now we don't do any classified research at Zucro Laboratories. That may change in a few years. We have a planned hypersonic building that will be going on site, and that will probably happen in a couple of years, and there will be classified research in that. But right now we don't have any classified research actually at Zucro Laboratories.
So the most sensitive work we do is industrial or ITAR. So for that you don't need a clearance, but you do need to be a U.S. person at least. There's another question.
Can I just say, there are some times where we have collaborations with national labs, and some of those, if you're going to go to the national lab to do an internship or work with the scientists there, some of them require some kind of clearance, more than the usual.
Okay, Jack has a question. Are there any professors working on research for missile propulsion specifically? My work is mainly focused on propellants and new propellants, not necessarily on the missile propulsion, the system itself. Anybody else want to add to that?
Steve, Professor Slaybaugh has a project, the Navy-funded project, in the solid fuel ramjets. That's notionally a missile propulsion project.
And Professor Pourpoint also has some work in similar areas. And then Chandra, let's see, do you encourage students conducting the research mixing both experimental and computational? I'd say it's more likely, Chandra, that it's one or the other, but some students do like to mix those together. Really depends on you and your advisor and the project that's available. Anybody else have a comment on that?
Yeah, it really depends on the capabilities of the students in a lot of ways. Some students can become expert at both, but you really need to make sure you don't lose focus during your master's or PhD research.
Patrick has a good question. How common is it for AAE students, aero students, to have advisors in ME or vice versa? That's extremely common. At some points, I'm primarily in ME, but I have a courtesy in aero, which means I could advise aero students just as well as ME students, and a lot of the aero faculty have that as well for ME. And at some points, I have more aero students than ME students, so that's all very common.
I would say most of the faculty at Zucro have joint appointments.
Yeah, and just because you're an aero, or ME doesn't mean you can take courses in either department. That doesn't, block you out of taking the courses you're interested in, as long as you have approval from your advisor committee.
Yeah, in many cases, students have co-advisors, one in ME, one in aero also.
And Terry mentioned that too, that there's a lot of co-advising, and it makes sense. For example, if I'm working on new materials and the characterization of that, Professor Meyer may be a great co-advisor bringing in the laser diagnostics. And so that's worked out really well with co-advisors, I think. It says, do students at Zucro collaborate on projects, or is work conducted more independently? There's both, but I do think there's a lot of collaborative projects, especially for the large projects that have a lot of complexity. There's a lot of collaboration, and there's certainly some work that goes on that are sort of what I call hobby projects or side projects, where at least I try to encourage my students to explore some things on their own and come up with some new ideas.
Yeah, I would say, so recently I had some students doing some work, measurements in a hypersonic tunnel at Purdue. 4 of my students were involved, and then multiple students at the hypersonic tunnel. In rotating detonation combustors, there might be 4 students plus a scientist involved. In energetic materials, there might be 4. It's really, it depends on case to case, but in a lot of projects, it requires not just 2 students, but even more. And so you might be working on a core project of your own, but you'll probably be exposed to a lot of other projects that will broaden your education, I would say.
Sydney, you have your hand up. Sorry I missed you earlier. Go ahead.
No problem. Yeah, Sydney here. I was curious, how do students at Zucro, who work at Zucro, get involved with helping out any private companies who come on the laboratory campus and need help?
With research, Sydney?
Yes.
We have that from time to time. In fact, we have 3 or 4 projects right now that the companies contact us, and we do some testing for them and those kinds of things. There's also programs called SBIRs and STTRs, where it's a small, focused, very much on a small business. And so we have, we team and put in joint proposals with small companies. I know Steve Heaster's involved with a small company near campus here, InSpace. I'm involved with a company, Next Offset Solutions, on additive manufacturing. And there's several other small businesses that we've collaborated with in the STTR and SBIR space. Does that answer your question?
Sort of. And I guess, how do the students become involved? Is that through the professor? Is
yeah,
that by asking themselves?
Yeah, generally, yeah.
Okay.
Yeah.
I did have a student that started his own company. He did a postdoc and then started his own company. There's a lot of support for that, and his company's doing really well. So if you're interested in starting a company, there's some resources for that. Bob, I think you were going to add a comment.
Yeah, we do about $20 million of research per year, and so there are a lot of different contract vehicles that are in place at Zucro Laboratories. But we do a lot of research for companies. Sometimes it's testing, sometimes it's more basic research that's sponsored by the companies. But in general, the professor would handle the contracting, and then the students would perform the actual experimental research.
Yeah, believe me, you don't want the paperwork, Sydney. let the professors deal with all that crap. You get to do the fun stuff. Okay, Hayden. Hey, how you doing, Hayden? It says, from past experiences, do the collaborative projects with external companies lead to job opportunities for graduated master's, PhD students? Oh yeah, I mean, we have a lot of contacts, and it's not necessarily that you work on your research for a particular company or funding source, and then that leads to that job opportunity. It may or may not, but we have a lot of interest in our graduates, both in industry as well as national labs. Anybody else want to add anything to that?
Yeah, I would say that the companies have a vested interest in recruiting the students that are working on their projects. Yeah, the worst comes when they work with a student for their entire project, and then the student goes to work for a different company. So more often than not, there's a big pull into the sponsors and the training that the student receives. But the students can really work anywhere.
Yeah. Bob, why don't you take this? Maybe you have the numbers. Typically, where do most people get their funding from? This is from John.
Well, let's see. I mean, the funding split is about 50% industrial and roughly 50% industrial, 50% from government agencies like NASA or Department of Energy. So we also, so most of the students at Zucro are on what's called research assistantships, if that's what you're asking about. We also have a number of students that are on fellowships like the NSF Fellowship, or there's a Department of Defense Fellowship called the NDSEG Fellowship. So that's typically where most of the funding comes from, either research assistantships or fellowships.
Okay, this will be the last question. I guess we're getting kicked off. It's as far as working in a national lab, is it typically expected to have a PhD or a master's degrees common in national labs? It really depends on the national lab. There's a lot of national labs that do hire masters as well as PhD. I think the difference between a PhD and a master's is what you want to do ultimately. If you're aiming more at more fundamental research or leading research groups, then a PhD is probably a better aim for you. If you're more interested in building things, and especially in industry, doesn't mean that there's no opportunities at national labs. There are. Then a master's is probably better. All right, thanks, Edwin. Okay, that's it. Please, send us an email if you want more information, and I encourage you all to apply to Purdue, and especially in the propulsion area.
Okay, thanks for attending.
Thanks, everybody.
And enjoy the rest of the Grad Expo.
Yeah.